Hi everyone, my name is Junyi. I'm currently a PhD student at MIT CSAIL, HCIE group, working with Professor Stefanie Mueller. My research focuses on creating interactive objects for which all functions are directly integrated with the form and fabricated in one go. Today I'm presenting my new project, a 3D design environment for both object form and electronic function, MorphSensor. MorphSensor is a 3D electronic design tool that enables designers to morph existing sensor modules of predefined 2D shape into freeform electronic component arrangement that better integrate with the 3D shape of a physical prototype. Let me show you the MorphSensor in more details. MorphSensor contains two parts: a 3D electronic design tool for designing electronic function in the context of physical prototype, and a fabrication pipeline to fabricate the resulting morphed sensor. Let me walk you through the MorphSensor system by an interactive soldering iron that detects the level of smoke in the air by an air quality sensor and warns you of the bad air quality so that you can take a break. Let's look at the MorphSensor 3D editor. We will start by importing the sensor module, in this case, an air quality sensor. The system extracts the sensor information from the board and its corresponding schematic file, and then sequentially creates the board and the individual electronic components as a set of 3D models. We want to measure air quality, and since the soldering frames are created by the tip of the iron, we want to place the air quality sensor close to the soldering tip. MorphSensor helps me with this by highlighting which part on the module does the actual sensing. You can snap and arrange individual electronic components on the 3D model using common 3D editing tools. After placing the active sensing part, I want to move all the relating passive components onto my prototype. I can use MorphSensor's auto placement function. During the entire editing process, MorphSensor maintains logic connectivity by tracking the logically connected pin locations and display a 3D air wire between the pins along the prototype geometry in real time. After positioning the electronic components, we're connecting physical wires based on logic air wires. Once wires join to the point at the end of the air wire, it is complete and connection is established. We'll go ahead and finish the wiring. We can still freely change the component location and rotation at any given time. We're able to expand the design anytime by importing additional sensors and components. In this case, a microcontroller for programming the air quality sensor and an LED to display the warning signal. Same as before, we will snap newly added components onto the model and connect them with the remaining circuit. When wire crosses, MorphSensor automatically adds a wire jumper, allowing both wires to be placed sufficiently. We'll then export design for fabrication using a lasso tool for marking out the desired area on the prototype. MorphSensor then converts the 3D circuit into a 2D projection with surface unrolling and export it as an SIGCHI file. Let's look at how we fabricate the morphed sensor. We developed a rapid fabrication technique that based on circuit stickers and extended with prefabricated PCB footprints, the Bigfoot, which are essentially slightly bigger SMT footprints for better connection. We'll first inject print the export circuit, put down some double-sided tape on the back for later object attachment. Take out the Bigfoot, soldering the corresponding components onto the Bigfoot. Then we'll attach the ECAD tape to the back of the Bigfoot, which are the conductive only through Z-axes. We'll attach the components to the circuit, and there you have it, the fabricated morph sensor. We'll go ahead and cut out the sensor, attach it to the object. Voila! This is your interactive object prototype rapidly built. Here are some of the interactive objects that we built using MorphSensor system. You can look at the paper for more details. If you like this work, I'll also present a paper at Chi 20 this year on curve boards, 3D breadboards that serves as a prototyping platform for functions in the context of object form. With that, I would like to conclude my super rapid 5-minute talk and open for any questions you may have. This project is funded by National Science Foundation. Thank you.